In the last video, we were looking at the contingency tables and how to read those, and we looked at some items where we were looking at the probability of one event or another event. So there's two different rules that we look at. The first one is the probability of event A or event B is the probability that event A happens plus the probability that event B happens. We subtract out their overlap, the probability of A and B happening together. That's because they can happen at the same time. So we have to remember to subtract out that overlap because these people right here, or individuals, were counted here as well as here, and we don't want to count things twice. In another situation, we looked at things that were called mutually exclusive. These are things that do not happen at the same time. Two events are said to be mutually exclusive if it is impossible for both events to occur at the same time. Think back on our previous examples where we were talking about the different types of degrees. So let me scroll back up here. So when we're looking at the different types of degrees, the last one we were talking about bachelor's or a doctorate. Well, these two things can't happen at the exact same time. So these two are mutually exclusive. Mutually exclusive would also be male versus female. You identify with one or the other. When this happens, it is strictly the probability of A plus the probability of event B happening. Since there is no overlap, there is no intersection, we do not subtract anything out. Another thing that we want to look at is the complement. When we're talking about the complement, if A is an event, the complement of A is the event that A does not occur. So the probability of being male, its complement is the probability of not being a male or being female. Those are complements of each other. We look at it several different ways. A with a C on the superscript up here is what we consider the complement of event A. Some authors use a bar over the event. Either one, it means anything that's not happening in that item. So when we look at the probability of A complement, this is 1 minus the probability that A occurs. The complement of A and the probability of A must add to 1 because it's one or the other. It's either this item or it's not this item. Those events must add up to 1. So I'd like for you to try some more of the probability with the addition, but also look at some of these complements and see if you have questions on those.